Hello everybody. In the previous session, we saw how ADAS software or for any functionality is developed. We saw the various types of in-loop testing. We saw the various types of unit testing, integration testing. We also saw the software development flow process. Now we will see after the software is exactly developed, how is it flashed into the ECU. Okay, here we go. Before we find out or we read about how ADAS software is flashed into ADAS ECU, we will briefly touch upon how any software is flashed into any ECU in general. Okay, flashing ECU into electronic control unit is a process of writing, updating, and replacing the firmware that controls the ECU's functionality. Okay, understand this sentence carefully. First you write, then you update or replace the firmware that controls the ECU's functionality. And now this process is used in automotive systems. It can be engine or transmission or ADAS or infotainment, industrial controllers or embedded system. And below we will see a general step-by-step explanation, how software is flashed into any ECU. Okay, now first we will touch upon the ECU firmware basics. Low-level software that runs on ECU's microcontroller, example STM32 or Infineon Tricore or NXP Power PCs. These are all the various types of ECU's microcontroller. Okay, and what are the various memory types in the ECU? It can be a flash memory, it can be a RAM memory, which is temporary execution memory, or EEPROM. Okay, all these memories, they have their own individual purposes. Okay, next is the bootloader, a small program in the ECU that manages firmware updates. Now next comes the tools needed for the flashing. What are the various tools required from the flashing? First is the diagnostic interface, the OBD port 2, which I have shown here in this particular drawing. This is the OBD port 2. This is the port through which the in-vehicle flashing happens. Next comes the JTAG or software debuggers for low-level flashing, the BDM, the background debug mode tools for direct MCU access, the CAN-LIN interfaces or vector canalizer or PCAN. In case you came from IC engine background and you have worked on any CRDA engines, I am pretty positive that you had a taste or you had a slight acquaintance with these devices or tools. Now, what are the various flashing devices? Flashing devices are pass-through, J2534 pass-through or bench flashing tools like KeyTag, PCM Flash, Autel Maxi Flash, and next comes the OEM tools like VCDs for Volkswagen, Forescan for Ford. Sometimes OEM develop their own flashing tools with which they flash the software into the ECU. Now, what are the various software tools? First and foremost thing, this is the file, the firmware file which is actually loaded or injected or flashed into the ECU. Okay, and flashing software depends upon the ECU. For example, OEM tools include BMW ISTA or Toyota TechStream, and there are some aftermarket tools also like Alien Tech Kiss, DimSport Genius, and there are some open source tools like OpenECU, ROM Rider for Subaru. Okay, so these are the tools used for the flashing software, and the protocols used are UDS most modern ECUs, KWP 2000, ISO 14230, XCP CCP, CAN ISO 15765. So these are all the various protocols used with the help of which the software is flashed. Now, now that we checked upon the various types of files, various types of flashing software, various types of the protocols used, we will see step by step how the software is actually flashed. First is you establish a communication. All right, we establish the communication, connect the flashing tool to the ECU via, it may be a OBD2 or it may be direct wiring if bench flashing is done. On next is you power the ECU 12-volt supply if not in the vehicle. Next is enter the bootloader programming mode. The ECU must switch from application mode to bootloader mode to accept new firmware. Okay, first of all, you must switch from application mode to the bootloader mode. If you cannot switch to bootloader mode, flashing is not acceptable. Flashing cannot be done so to accept the new firmware. And how is it done? With the help of diagnostic command or the hardware trigger. First, you erase the old firmware. The existing firmware is erased to make space for the new one. Alright, commands like UDS, O by 31, O by 01, this will directly erase the memory. And it also, there are some UCUs which erase in blocks, sector by sector. Okay, now in case you are coming from core mechanical or automotive background, if you find these things are very intimidating, I thoroughly recommend all of you to go through some of the videos in YouTube or some material in the internet so that you can get a clear cut idea, because explaining how this is done in an elaborate manner is going to take a lot of time. It is well beyond the scope of this particular tutorial. Okay, and but nevertheless I am pretty positive, in case you come from powertrain or body control module or transmission control module, you are already familiar with this particular process. But anyway, I am going to repeat here. Next comes the transfer new firmware. The flashing tool sends the firmware in data packets, usually 512 bytes to 4 KB chunks, and checksums are verified for integrity. Now UDS commands used are 0 by 34 to request the download, 0 by 36 to transfer the data, and 0 by 37 to request exit transfer. Okay, it is only after you give the command 0 by 37 the session is ended. Next comes the verifying and resetting the ECU. The ECU checks the firmware integrity and a reset command reboots the ECU. And some ECUs they require reprogramming EEPROM data, EEPROM data, which includes win and calibration. And what are the actual steps you do after the flashing? What are the post flash steps? Post flash steps is coding and adaptation, ECU calibration, and functional test. These are the post flash steps. Now let's briefly touch upon the security and authentication. Most modern ECUs have security measures to prevent unauthorized flashing. So, and moreover, most of the OEMs they take every precaution to ensure unauthorized flashing doesn't happen. They ensure that no unauthorized person can download or inject any unacceptable software into the ECU. First is secure boot, only accept signed firmware for the OEM. Next is seed key authentication. The tool must solve a cryptographic challenge. Win locking. Okay, next comes the win locking, where some rejects the form, where ECUs reject the firmware if win doesn't match. So win, the vehicle identification number, is like a password. Okay, if the password or the win is not matching, then ECUs reject the software. Next comes the hardware security module. Encrypted firmware updates. Okay, so this hardware security model, it ensures that the firmware updates is thoroughly encrypted. All right, now we have seen the types of flashing. Let's briefly touch upon the summary. One is this OBD flashing, next is the bench flashing, boot mode flashing, and the wireless flashing, which is the OTA. This is the most state of art software flashing methods, especially used in ADAS. Okay, OBD flashing done via the cars diagnostic port. This has this is standard updates and dealerships. This is how most of the standard software flashing happens. Next is bench flashing, ECU removed and flashed externally. Next is boot mode flashing directly via the BDM or SWD or JTAG. And next, of course, is the wireless OTA, over the air updates, Tesla and modern cars. Okay, now what are the various risks and challenges? First important risk is breaking the ECU. If the flash fails or power is lost, so as the flashing is happening, suddenly power is lost, then the flashing also fails. This particular phenomenon is called bricking the ECU. Next is compatibility issues, wrong firmware version. Now this happens very rarely because nowadays OEMs are taking every precautions that the only the correct firmware is flashed with the help of WIN or with the help of the correct encryption. The compatibility issues are almost eliminated, but still there are some rare chances that compatibility issues may arise. Next comes the leadership locks. Some ECUs only accept OEM tools, and security locks they require seed key or cryptographic authentication. Okay, so in case this cryptographic authentication is required, then this is a very tedious process how to say decrypt the cryptography authentication. So that's a very tedious process. Next, in conclusion, flashing the software involves connecting, entering the boot mode loader phase, then erasing the old firmware. Next is transferring new firmware in chunks, verify and ECU, and post flash coding and calibration. Now, this is how exactly any software is flashed into any ECU. Now we will see elaborately how ADAS software is flashed into ADAS ECU.